So I'm not sure which matrix you came up with, but whenever I go to think about this, an example that I go to right away is something that involves a shear or a skew. Usually that's not going to commute. That's the mathematical term for this. So I can't, if I shear first and then do something, it's not the same as doing that thing and then shear. So if I just look at a shear in X, so the one that goes like that, followed by a flip in X, let's actually look at that here. So I'm doing a shear first, so 1, 1, 0, 1, and then I'm doing a flip, negative 1, 0, 0, 1. So the shear by itself would do that, the flip by itself would do that, and together they do this. Okay, you see that? So it's interesting. All right, and I can actually show you right here that if I flip these, they won't do the same thing. So let me do the flip first, and then the shear. And so actually, I guess I should probably, okay, no, this is fine, I'll do it here. So keep this this picture in your mind. And now let's do the flip first and then the shear. And you can see they're just not the same thing at all. Okay. So we say that this does not commute. They give you two different results. Okay, so I just wanted to mention that. So one of them looks like this, the other one looks like this. And they're very different. Okay. So order matters, it's very important. And you're going to get confused as you do this. You'll see. You have to sometimes think pretty hard about, well, which one do I want to do first? Okay. One more thing I want to talk about real quick is what's called an inverse. So an inverse is actually something that will cancel out the result when you commute it. So for example, if I have a flip like this, a flip is its own inverse. So if I do a flip followed by a flip in X, it'll get me back to where I started. Another way of saying that is if I multiply this matrix, if I multiply A by B, and A and B are inverses of each other, then I should get back the identity matrix 1, 0, 0, 1. Okay. So for example, if I go back to that rotation matrix, which was approximately, so if I rotate counterclockwise by 45 degrees, so if I say 0.71, negative 0.71, I'm approximating it, it's not exactly right, but actually this should be a negative 0.71. 0.71, 0.71. So remember, that's my 45 degree counterclockwise rotation. Why is that not doing anything? Sorry, 0.71, negative 0.71, 0.71, 0.71. Okay. There we go. So 45 degree counterclockwise rotation. So pause a moment and think, well, how would I undo a counterclockwise rotation? So you have to do a clockwise rotation by the exact same amount. And so what that is actually is this matrix. So it would be still 0.71, but actually a positive 0.71 there, and a negative 0.71 there. Okay, so let's just check that. So this one's going counterclockwise 45 degrees, this one's going clockwise 45. And now you'll see if you do them both together, they cancel each other out. So those are called inverses. And again, you can just do this in GL matrix. So let me show you real quick. So if I say, there's a class called mat2. I'll just make a shorthand for that real quick. So if I say, let me set that one up. So if I say, let my matrix M, or I'll say A, is equal to mat2.from values. So we're going to 0.71, negative 0.71, 0.71, 0.71. So we specify this in what's called row major order. So we give the first row first, and then the next row. what I can do is create another matrix and say let B is equal to mat2.create, and I can say, oops, create. Okay, it doesn't like I already declared B, so I gotta get rid of that. Okay, there we go. So actually by default it just makes an identity matrix. You see 1 0 0 1. Now I can say mat2.invert. So the result is going to be stored in B, and I want it to be the inverse of A. So I see it's not, it's not exact what I said, but it's basically what I said. 0.71, 0.71, negative 0.71. So you see the negative goes down there. 0.71. Okay. So let me do another example. Let's try to figure out what is the inverse of this skew here, or the shear. The shear that moves me over shear next. So let me say A is equal to mat2.from values 1 1 0 1. Oh, I refreshed. I have to say mat2 is equal to GL matrix dot mat2. Okay. Okay, so now I'll say mat2.invert. And I got to allocate my B too, so I have to say B is equal to mat2.create. mat2.invert B. Okay. Okay, so it turns out the inverse of this skew is 1, negative 1, 0, 1. So I don't know about you, but I wouldn't have guessed that off the top of my head, but let's look and see. So this matrix by itself does that shear. This matrix by itself does that. It actually does a shear and a flip like we were looking at. And together, if I do the shear first and then I do the shear and the flip, hey, it takes me back. Pretty cool, right? All right, so that's what a matrix inverse is. And actually, the other thing I'm showing over here, if you scroll over, you can actually do them. You can do the pre-multiply and just look at the result. Here it does nothing because these are inverses of each other. But if let's say that I did a scale here. So you could mess around with this, but if I did a shear first and then a scale, then it would animate like that, shear first, then scale. Or it does them all in one shot, right? If you pre-multiply, it just does it all in one shot. Just like that. Okay. So I'm going to have you do a quick exercise where you find the inverse of another rotation matrix that's not one we've looked at so far.